I would like to talk to you about microfrontends. So, working as a web developer, working in this field is quite crazy compared to other professions. So the tools we are using, the ways we are building things are changing quite rapidly. I've put together a simple timeline with popular frameworks or libraries over since 2005, and you see quite a lot of change, and things get replaced or new things come into play. And I think this is a good trend because we get ideas from different domains, from different people, from different processes to our community. And yes, it would be foolish to assume that we've reached the end here, so I think this will go on. And another trend is that the things we are building are not small anymore. So we all work on projects that get bigger and bigger. You are not the only web person, I would guess, in your company. And after a certain point, the things get hard to manage. So the software reaches a size where it's not possible for one developer to fit everything into his head. These two trends combined, we are quite comfortable on starting a big project and basing it on one single library. So choosing React for everything we try to build, for example. Yes, and we have to be careful that we don't end up there. So does anyone know which movie this is from? Yes, Lego Movie. If you haven't seen it, watch it. Awesome movie. President's business office in the infinite floor. Okay, but today I would like to talk to you about microfrontend or how to avoid building a front-end monolith. So who am I? I'm Michael. I'm a front-end developer at a company called Neuland. It's a company based in Bremen, in Germany, and we build e-commerce solutions. So we work together with bigger clients who struggle doing their e-commerce in-house or who have realized that they need to do their e-commerce in-house, and we come in and try to help building and enabling them to build a future-proof platform. Okay, microfrontend, it's quite a buzzwordy term, so micro and front end, and it's not quite clear what it is. So is it building smaller front ends or doing microservices in the front end, which sounds really scary? But I can assure you it's not that, none of those. The term microfrontends is quite new. Before, the concept that microfrontend describes went under the name verticalized teams or self-contained systems or vertical decomposition with UI composition, which is quite bulky and hard to remember, but they all describe basically the same thing, and the micro-frontends term has a more front-end perspective on doing this kind of architecture. So my talk will be split into 3 parts. The first part is I will tell you about what microfrontends are. The second part, why you should care, why this is better than not doing it, or maybe if it fits for you at all. Oops. And the third part is I will show you an example on how to implement microfrontends and what are the challenges you have to manage. So back in the days, software development was quite easy. You had a software project, web project, for example, one project, a couple of people on the team, and it had a small front-end aspect. So you had one CSS file and one CSS file where everyone contributed CSS to at the end of the file, a few templates, a jQuery, and a little bit of JavaScript files. But over time, the front-end grew. So it's common that in a project you have dedicated front-end people who work together, and in many projects it's also the case that the front-end and the back-end people don't work in the same room or are located in different teams. So they have an API which they talk to each other, for example. And at a certain size, the backend people realized that adding more people to the backend wasn't the solution for scaling. So things got complicated, and the thing they came up with was doing microservices. So you have split up your backend into multiple parts. You have a product service. I'm coming from the e-commerce world here. You have a product service, a pricing service, availability service, whatever. Small services, self-contained, easy to manage, easy to work with. But the front end stayed the same. So no changes in the front end. But to make this work, there typically is some layer added in between, often called API gateway, which uses a REST interface and collects all the calls and distributes them back, or maybe it's built with GraphQL. Doesn't matter, but as you see with this slide, this is quite complicated. So you have the front-end people, you have this gateway stuff, you have this zoo of microservices, and when you want to implement a new feature, you have to manage a few things. And the micro-frontends approach it takes a quite different approach on this. So instead of slicing out to individual pieces, you create vertical slices across your complete application. So you take your application or take your business and slice it vertically and have different teams. So in our case, e-commerce, this is an example with 4 teams. So you have Team Inspire, which mission it is to inspire the customer to find a new product, for example. You have Team Search for the people who know what they're looking for and just want to have the quickest way. Team Decide. And when we look at one team, each of these verticals run by one cross-functional team. So you have one team with front-end developers, back-end developers, maybe UX people or graphic designers, but also product owners. So you have one team with interdisciplinary people in it. And each team is assigned a specific mission. In this case, the name is Team Search, so they are responsible for helping the customer finding stuff in your application or in your shop. And each team also stores its own data, so there's no central data model, data store. Each team stores its own data and manages it. And the most important part, each team ships its own user interface, or part of the user interface. And yes, teams should be as autonomous as possible, and they can choose the tech stack they think which is best for accomplishing their mission. And when you've looked into microservices, the things that are on the slide here, they really sound like things you would describe microservices with. And in fact, this smells like a fat and tall microservice with added UI in it. Okay, how do we use it? So at our company, we have 4 customer projects, all e-commerce, and the number of slices per customer is quite different. We have a customer who only has 2 slices right now, but we also have customers who have 7 or more slices or teams that work with each other. And the team size also varies, so typical team size is 4 to 8 people, for example. But we are not the only one. We haven't invented this kind of working. There are many companies who internally are structured like this. Most famous one, I think, is Amazon. Amazon is quite secretive about how they work, how they are structured internally, so you can't read many official documents from Amazon, but other companies like Otto, which is a big German retailer, but also IKEA or Zalando are organized in this way and work like this. Okay, so now why should I care? So I also mentioned a few hints on why this might be better, but I will go to a few more. Yes, the most important thing is development speed. So being able to react quickly, to develop features more quickly. And you achieve this with building smaller teams and small autonomous teams. So the autonomous part is really important. So the team should have everything it needs to fulfill their mission and to come up with new things, experiment, try out stuff, throw away stuff, and start over without having to cooperate with all people in the organization. And another important part is each team has a customer focus. So you don't have pure backend teams who just deliver APIs, for example, and specialize in doing the best pricing service with an API. All teams, all developers are in one team that ships software directly to the customer. I think this is one of my favorite slide images. I'm not quite sure if this one is a happy customer with a new power tool or if it's a crazy backend guy who's trying to murder you. Okay, another important part, my favorite part in working with this kind of model is you have reduced scope. So you are not responsible for the whole shop, for the whole front end anymore, which at first is a little bit scary because other people do stuff you have no saying in. But working this is quite comfortable because you come back to the point where you know everything that goes on in your front end because the scope is limited. You are, for example, only responsible for delivering a good search, and you are not responsible to also do risk management and fraud detection and whatever in parallel. So everything fits into memory, and I don't mean browser or computer memory, I mean my own memory. Another important aspect is that front-end renovation, or in general, throwing stuff away, making stuff newer, improving stuff gets a lot of easier because you can decide in your team, and yeah, you can just do it. Okay, so how do we implement this? This is basic structure. In this example, we have a site with 5 different pages, and each page is owned by one team. So we have the home page and the product list, who are both owned by the Inspire team. You have the detail page, which is owned by the Decide team, for example. And these pages are connected via links. Everything is fine, quite easy. But when you go deeper in, you see that's not quite that easy. This is a simple product page, for example, with a big image. You can choose the color of your tractor. You can see related products or products that might fit. You can also have a mini card at the top. And there are a lot of things going on here. So the page itself is owned by the team Decide, who helps the customer to make a good buying decision. But the page also contains other parts, like the recommendation box on the right side. This is the job of Team Inspire. This is what we call a fragment. So the Decide team doesn't know how to do product recommendations itself, but they can include a piece of UI from the Inspire team. Same goes for doing the checkout. So the Add to Cart button and the connected mini card in here. Okay, so now how would we do this? We could decide to come up with iframes again and do piece or page together with iframes, but I think we can all agree that there's many problems connected with iframes, accessibility, search engine optimization, performance, whatever. We don't want to use iframes. Yeah, but we want to have an integration model in the browser. So there is this thing that was promised 6 years ago, and next year will be the year of, and it never was, and this is web components. So in the last year, things started to change. So more and more browsers really did implement web components, and web components itself is an umbrella term. So it consists of HTML imports, HTML template, shadow DOM, and custom elements. And yeah, HTML imports, Firefox decided not to implement it, so it's gone. I think no one talks about HTML imports anymore. And the thing we will focus on here is the custom element. So the custom element is this feature where the browser lets you define or come up with your own HTML elements. So you can say, I want an element that is called checkout-basket. And the only thing the standards require is that you have to put a hyphen in there to avoid forward or conflicts with newer HTML elements. And this is how you do this. You can call custom element.define, specify the name of the component you want to register. and then provide an ES6 class, and this ES6 class has a number of callbacks you can choose to implement. So in this example, yes, you have the connected callback. This one is called every time the browser finds your checkout basket element somewhere in the DOM. Then your code will be called, and it's up to you what you do in there, how you make your mini basket, your checkout basket visible here. So you can just do it via plain JavaScript, load server-rendered HTML via Ajax, for example. But you can also spin up your mini React application in here if it's the right thing to do. Okay, and there are also a few other callbacks. So you have a constructor, which is called a little bit before the connected callback. You have the attribute change callback. This is quite interesting. So every time a property, an HTML attribute on your custom element changes, you get this callback and you can react to this. And you also get the disconnected callback, so you can clean up events you might have registered. And an interesting part is that many newer frameworks now do custom elements by default. So you have libraries like, or they don't call themselves frameworks anymore. So Stencil and Svelte, for example, use custom elements as their component model, and they output a thing that is custom element in itself. And also Angular with Angular elements goes in this direction. So browser support. Last week, Firefox nightly switched on custom elements, or I think all of web components, by default. Up until now, it was always behind a feature flag, but in one of the next versions of Firefox, this will also be enabled. In Edge, it's still under consideration, but in practice, it's not a big problem because custom elements can easily be polyfills. There's an API called Mutation Observer API, supported by all major browsers, including IE11, and there's a polyfill, or there are many polyfills that can recreate the custom element behavior we saw before, even in older browsers. Okay, so this is how our page now looks like in markup view. So the team decide owns the complete page, and the places where the recommendation box, for example, should be, that you only have this, this custom element tag, which specifies which SKU you want recommendations for, and everything is good. So the product detail team doesn't have to know anything about the internals of the Inspire team. They just have to know how the element is called and what attributes it has. So now when we come to interaction, so if the customer wants to choose the green tractor, maybe you have other recommendations. So the thing that the decide team, the product detail team, has to do is just change the SKUs, so change from red to green, and it's up to the Inspire team to update their component and to reflect this change and show new products that might fit. So basically, the API between the teams is just the DOM. So if you know how to use the DOM, how to manipulate the DOM, and everyone knows that, you're good to go. And you can also use custom events, for example, to notify the page that something happened inside your fragment, for example, without coming up with your own implementation. So in practice, each team which provides fragments has to specify what their names are, the element names, the attributes, and maybe events that can bubble from it. Framework support, so Rob Dodson from Google has built a site which is called Custom Elements Everywhere, which is a compatibility test suite where you can checks different frameworks on how good they play together with custom elements. And the bottom line is most frameworks are quite good. There are a few edge cases, especially in React, with special types and passing things around that are still a little bit tricky, but in general it works quite good. Okay, so up until now, make it a little bit. Yes. Up until now, we always assume that JavaScript is enabled, JavaScript is loaded, JavaScript is fast, and if we don't have JavaScript, we don't have custom elements, so custom elements just behave like an empty div, and parts of our page are missing. And this is not a good thing, because what we should do is building for progressive enhancement. So when things break, it should be possible to use your site. So it's a bad excuse to say, oh, my JavaScript is broken, so the customer isn't able to buy my products anymore. And you can't always rely that the JavaScript works, because you have third-party scripts and ad blockers and whatever that make it hard to do this assumption. Jeremy Keyes came up with this term resilient web design, which I like even better than progressive enhancement, where he talks about why it is very important to use the fundamental web technologies and care about how your stuff works when JavaScript is not disabled or JavaScript failed. So if you want to learn more, I recommend looking up resilient web design. He did a podcast, ebook, and many materials, and also talks about this topic. So we need a way to also render this stuff on the server. And there is a technology, quite an old technology, which is called server-side includes, which are just basic HTML comments with special syntax where you can add a URL. And most web servers support it. This is a screenshot from a book from 2001. Yes, 2001. And when this book it's not JavaScript, it's HTML and CSS. When this book was published, server-side includes were already an old technology. So they are built into most web servers today. And yes, this page states that the easiest way to import external content into your web page is to use a server-side include. So back in the days, we used server-side includes to show the current date on a website, for example. Okay, how do server-side includes work? So basically, you have a browser who wants to call a URL. He makes a request. The request goes to the web server. I've put in Nginx here, but it also works with Apache, for example. The web server decides which team is responsible for this URL, forwards the request to the team. The decide team with the product page delivers the complete HTML from top to bottom and includes or adds the HTML comments in the places where the fragments should be. The web server parses it and makes two calls to the checkout team for both components. So for the basket component and also for the buy button component. These requests are done in parallel. So when the response gets back from both fragments, the web server assembles this content and then delivers it to the browser. There are also other techniques like edge-side includes, for example, which basically works the same. And there are also other companies who build this in other technologies. So you have Java implementations or Node.js implementation in this if you don't want to use the web server. Okay, but we still have the problem that web components are not defined in serverland. So web components are a concept which just exists in the browser up until today. But luckily, most of our templating languages or frameworks support universal rendering. So it's quite possible to render the content of a fragment on the server and render the same thing on the client. And we can use this fact and combine both approaches so that on the first load, you get the content of the custom element rendered from the server. And from there on, the client can handle further interactions. So then when an attribute changed, the client can re-render and fetch data and re-render the content without having to contact the server for HTML or without having to refresh the whole page. Okay, and this is what the example would look like. Okay, another topic, page transitions. So we had the slide before where all the pages are owned by other teams and they're connected via links. And classical links always involve reloads, and reloads are not as fast as not reloads. So it is, if you can do it, it's better and faster and better user experience to avoid the reload. And there are multiple solutions on solving this in the micro-frontends context. So if you have a small number of teams, for example, here we have 2 teams, Team A and Team B. Team A has 2 pages, Team B has 2 pages, for example. Then each team can implement their own routing, their own soft navigation. So when you go from the list to the product page and back, this will be updated, rendered on the client with DOM diffing and everything. Same goes for links inside of Team B. But you have hard navigations when you cross team boundaries. So when you go from the product page to the cart page, the whole page will be reloaded and team B is in control, for example. This is a very simple solution because it's up to the team to decide if they want it, if they want the complexity and if it's worth. But the downside is with the growing number of teams, you get more and more hard navigation. So you have fewer spots where client-side routing will actually do its work. Another alternative is to use some kind of HTML shell or app shell, so a combined thin layer of application which, for example, handles the routing. And the teams itself don't deliver the complete HTML of the page, they just deliver some kind of page fragment, so fragment, but the fragment spans the whole body, for example. And the common router will transfer control or swap out these fragments. This is one possible solution. You can also look at a framework or a library called single SPA. This is a ready-to-use library which has code examples for many frameworks. Yeah, it's a little bit another approach, but could be interesting. Okay, but there's definitely a set of things that you don't want that every team comes up with their own thing. So polyfills, for example, you want to, when you deliver a fragment, you don't want that your fragment also contains the polyfill for doing fetch, for example. You should come together with all teams and agree on a fixed set of JavaScript polyfills, for example, basic typography, and if you still need them, CSS resets. And things that you can also think about is doing a centralized tracking, centralized error reporting, real user monitoring, or these application shell I showed before. Yeah, they can be value in don't having it centrally, so each team can play around, update without having to notify other teams, but this is stuff you have to work out. And now the most important thing, when we have 5 teams that all deliver their own HTML or deliver fragments, you don't want the user to know that you've internally structured this page in 5 teams. So from a user's perspective, the page should have a coherent look and yeah, a button should look the same across the complete page. There are companies like Amazon where you think it's, when you look across Amazon pages, for example, the button always looks different on every page, but most of our customers, it's important that these things have a coherent look. Okay, there are basically 2 ways of achieving this. The one way is the global style sheet way, or the bootstrap way, as we call it in our company. So you basically have one big CSS file, and this CSS file contains styling for all components, which are part of the pattern library, or part of the style guide. And it's really easy to use for the teams because the teams just have to add HTML classes in their markup. It doesn't matter how they generate this markup. And you always have a consistent look, so a button in one place also always looks like the button in another place. But the downside is that you now have a big global CSS file. You don't have any way to track which styles are used, which styles are not used anymore, and it's also very hard to make breaking changes. So changes that require changing classes, require changing internal markup, gets very hard, and in practice, instead of making a breaking change, you just build a new component which has a different class name or a v2 in its class name, and things get out of hand very quickly if you do this for a long time. And another approach is to deliver a version package. So have your pattern library bundled or delivered as one NPM package, and this package contains not only the styles but also real components, so an HTML template that the teams just can use. So if they want to instantiate a slider, for example, they can just do the slider component and don't have to know all internal markup from there. The pros are that now only the CSS is shipped that is already that is used. So if you deliver a fragment which only has a headline and a button, you only need to ship the headline and the button CSS with your fragment. You have the chance of redundancy, so when all fragments use the button, yes, you have the CSS of the button in all fragments, but in practice, having this mechanism to only ship the things you use end up being much smaller than bundling everything up beforehand. The downside is now every team has to have a build process. Okay, you didn't have to use it with the other concept. A more challenging problem is that you need a common templating language to effectively do this, or have different versions of your pattern library, of your style guide for different frameworks, for example, because there is no universally renderable and framework interchangeable templating language. So JSX is, many frameworks use JSX. This might be a candidate, but we don't have a proper solution here. There is a little bit of work going on with the template element. Up until now, the template element is just a dumb piece of markup you can copy efficiently, but Apple, end of last year, has published a proposal where they think about how to do conditionals, loops, and interpolation, for example, in the template element. So it's an interesting thing. I will have the link in the slides, so if it interests you, you can look in there. Yes, performance. This is a topic many people bring up when they hear Microservices for the first time, because it sounds crazy to use not one JavaScript framework, but more JavaScript frameworks. And yes, it is a problem. The obvious solution is be reasonable. So if you want to ship a mini basket, for example, do you really need React to do a mini basket, or can you get away with doing this in a more smaller, more efficient way, or do you really need a framework? And I don't recommend using all frameworks you can find together in one page. And yes. Most important part to come to a solid discussion is to set up a performance budget, measure your performance on a regular basis, and know your numbers. So if things get out of hand, it should be pretty easy to know where the slowdown comes from. Okay, some last things. Don't share state. I think it's obvious. So if you want to have isolated teams, don't share one global variable where you exchange data with, for example. Value team independence. Working in this and coming from being the only front-end developer, it's quite tempting to want that all front-end parts are created the same. So everything looks the same. Code formatting should be the same. It's tempting, but try to resist and try to give each team the room they need to do their stuff. Learn from your colleagues. So when you have a cross-functional team, you sit together not with other front-end people, but also with back-end people and other people. Use this, learn from them, but also teach them. So we started in our company to teach back-end developers CSS, and it's really great because they know they more understand why we do stuff the way we do. But they also lose the fear of the thing that they don't know and just always breaks when they touch it. Yeah, talk to your neighbors, talk to the other teams, so don't reinvent everything, share best practices. Ownership is very important, so all your fragments, all your pages come up or end up in the same browser, in the same runtime. If something goes wrong, it should be as easy as, or it has to be easy to find out what causes this problem. So have prefixes, team prefixes for cookie names, for local storage entries, so that you don't collide it, but also that it's easy for you to know what happened. Okay, that's it. Thanks for listening.
Thank you. All right, we have questions. All right, one you touched on about, one question was about how to keep the UX consistent, but you talked about the importance of having a design system. Yes. So, another one is, what is version control like, and what do you do to test release candidates across small teams?
Everything gets easier. So each team is responsible for doing their own version controls, to deciding if they want to do continuous delivery or if they want to have a QA step or whatever. In our projects, the team decide themselves. Most tend to go to a more automated testing way, but it's up to the team. So there's no specialty in the microfrontends way. But there is a thing that you have to, at a company level, you need to get the acceptance that each team has control and there's no central person who can say, okay, today I want to check all pages, and then each team is able to deploy. We try not to do that.
Yeah. Okay, and so you mentioned it's important to talk to the other teams, talk to your neighbors. Is there any kind of system in place for doing that, or is it you just assume people will talk to each other, or?
In practice, we have a concept called guilds. So we have a regular weekly, bi-weekly schedule where all front-end people, all back-end people, all database, whatever, people from one profession join and talk to each other for an hour and show what they've built, and other ones give feedback, and you share stuff. And maybe you copy the code from the other team because you think it's a better solution than the solution you came up with. Yes.
Okay, great. Thank you. All right, get round of applause.
Thank you.